Dear students, earlier we have learned light reflection by spherical mirrors. Especially we learnt about concave mirror. Now we are going to learn ray diagrams formed by convex mirror. Image formation by convex mirror. What is the nature and the position of the image when the object is at infinity in front of a convex mirror? This is the question. When an object is placed at infinity in front of a convex mirror, the reflected rays appear to come from a single point behind the mirror. See here, when an object is placed at infinity in front of a convex mirror, the reflected rays appear to come from a single point behind the mirror. Image characteristics, nature of image, virtual and direct. Position of image at the focus behind the mirror. Size of image highly diminished. Point sized image. See the explanation. Parallel rays from a distant object fall on the convex mirror. These rays diverge after reflection. When the reflected rays are extended backward, they appear to meet at the focus F behind the mirror. Since the rays do not actually meet, the image formed is virtual. Therefore, the image cannot be obtained on a screen. See, this is the diagram. Object we have taken at infinity. At a longer distance we have taken the object AB. This is the parallel ray coming from the object. This is the parallel ray. When it falls on the convex mirror, it will reflect. How it is getting reflected? It is diverging. Diverging means it is going away from the principal axis. This is principal axis. It is reflecting. How it is getting reflected? It is going away from the principal axis. This is a parallel ray. This is also diverging. Whenever it falls on the convex mirror, it is diverging. Diverging means it is going away from the principal axis. If you extend back the reflected rays, this is reflected ray. If you extend it back, it meet at the focus. This is reflected ray. It is going away from the principal axis. If you extend it back, these two rays are intersecting at focus. These two rays are intersecting at focus. So where you are getting the image, you are getting the image at the focus. So these rays are appearing that they are coming from the focus. This ray appears that this is coming from focus. So the image is formed at focus. This is virtual image. This is virtual image, and it is point size image. That means it is diminished. So this is object and this is image of the object. This is highly diminished image, and this is erect image, upright image. You are getting upright image only, but it is point sized image you are getting. What happens to the size and position of image as the object is moved closer to the convex mirror? Now you are moving the object closer to the convex mirror. You are taking the object closer to the convex mirror. In the first case you have taken at a longer distance, and then you can take at any position nearer to the convex mirror. As the object is moved closer to a convex mirror, certain changes occur in the image formation. Coming to size, the image becomes slightly larger as the object moves closer to the mirror. Image becomes slightly larger as the object moves closer to the mirror. However, it still remains a diminished position of the image. The image moves closer to the pole P. It always remains behind the mirror between P and F. So position of image. Image moves closer to the pole P. It always remains behind the mirror between pole and focus. Nature of the image. The image is always virtual and erect. Image is always virtual and erect image. This is a ray diagram. So this is the parallel ray coming from the object. It is getting divergent. The reflected ray is diverging. Another ray I am considering. This is the ray appears that it go through the center of curvature. This ray I am considering. After reflection, it will retrace the same path. It will reflect in the same path because this is the normal. The ray which is passing through center of curvature is normal. So it will reflect in the same path. So reflected ray, the ray which is divergent, if you extend back, these two rays are intersecting in between pole and focus. Wherever these two rays are intersecting, there you can draw the image. So this is the object and you are getting the image. ST is object, S dash T dash I have taken it as image. So this is image. So object, image is diminished, right? So compared to object size, this is diminished. However, at the focus highly diminished. But if you are moving this object, if you are moving closer to the mirror, closer to the convex mirror, so image is moving towards a pole and slightly increasing, that you can observe. Summary table, convex mirror image formation, object position far from the mirror. If you take object far from the mirror, highly diminished image you are getting. Yet focus, near focus, behind the mirror you are getting. So nature of image, virtual and erect image. Close to the mirror, object position close to the mirror. Image size slightly larger compared to earlier case, it is slightly larger, but anyway it is a diminished image only. Closer to pole P, image position closer to pole P, behind the mirror only, it is the image is formed. So nature of image, virtual and erect image. Why does a convex mirror always form a virtual and a diminished image? Coming to answer, a convex mirror always forms a virtual and a diminished image because it's a curved it's a curved outward reflecting surfaces, curved outward curved outward reflecting surface causes light rays to diverge after reflection. So curved outward reflecting surface causes light rays to diverge after reflection. Diverge means going away from the principal axis. Diverging nature of reflected rays. The reflected surface of a convex mirror bulges outward. Reflecting surface of convex mirror bulges outward. This causes the reflected rays to spread apart, that is diverge. These diverging rays appear to come from a common point behind the mirror. So these diverging rays appear to come from a common point behind the mirror. However, the rays never actually meet. The rays never actually meet. Virtual image formation. Since the reflected rays do not actually meet, a real image cannot be formed. The brain traces the reflected rays backward. Our brain traces the reflected rays backward. These extensions appear to meet behind the mirror. Therefore, the image formed is virtual and erect. The image formed is virtual and erect. Diminished image. Because the reflected rays are spread out, the image formed is smaller than the object. Hence, the image is diminished. When the object moves closer to the mirror, the image becomes slightly larger. However, it still remains smaller than the object. It still remains smaller than the object. However, we are having diminished image. Conclusion: a convex mirror always forms a virtual, erect and diminished image. What is our conclusion? A convex mirror always forms a virtual, erect and diminished image. The image forms behind the mirror. This happens regardless of the object position.